Organic chemistry is a discipline that focuses on carbon-based compounds. If you look at your new cheat sheet, the first sentence says organic compounds contain carbon atoms. However, not all carbon-containing compounds are classified as organic. There's a few exceptions, such as sodium carbonate, carbon monoxide, and carbon dioxide. But we won't focus too much on telling the difference on whether it's organic or whether it's not. We're just going to focus on some characteristics of organics, but mostly nomenclature. We'll be doing a new naming system today. Organic chemistry is a very deep topic because of the dynamics of carbon. Carbon's an awesome element. If you look at his location, he's in that section where we didn't have an oxidation state labeled above him. He's, again, very dynamic in regard to the characteristics and attributes that organic compounds can have. One of the really cool things about organic compounds is the isomers that they can form. During yesterday's introduction assignment, the very first question you were asked to answer had you analyze that was Kevin Hernandez. Had you analyze some isomers of what's known as pentane. But what's cool about it is that if you take C5H12, you can organize the 5 carbons and the 12 hydrogens in some different arrangements. And based off those different arrangements, it changes the attributes of pentane. When pentane is arranged like this, it reacts in the environment in a certain way. But when we rearrange the C's and the H's to look like this, it acts in the environment a different way. Same compound, different attributes. This idea is known as having isomers, different arrangements of the same carbon compound. But I can tell right away that I'm looking at organic compounds here because one of the big things you want to walk away with today is the focus that organic compounds contain carbon. So when you run into questions on your new online assignment that says, is this organic or is this not? For our purposes, the question is really asking you, is carbon present? There's a list on the front of your cheat sheet that says meth, F, prop, bute, pent, hex, hept, oct, known, dec. I've got it written on that far whiteboard over there. Write yourself a note next to that list that says memorize. You need to memorize the organic prefixes. I don't anticipate that you're going to have trouble naming the organic compounds in a moment, but if you don't know those 10 prefixes, then you won't be able to do it, and I won't give it to you on the test. Flip to the back of the cheat sheet. What you'll notice is we're going to focus on the simplest type of organic compound. They're called hydrocarbons. Hydrocarbons, as the name suggests, are compounds that contain just carbon and hydrogen. They're organic because of their carbon part, and they actually cover some substances that you're familiar with, like propane. Where do you deal with propane at? What's that? Cooking, right? If you have a grill in your backyard that your parents cook on, it's probably got propane gas inside of it, which is an organic compound, right? Or butane is what's commonly found in a lighter that you would buy at a convenience store. What we're going to look at today is how those items are actually hydrocarbons, and I want to show you how to do their nomenclature, write their formulas and their names. One of the things on the back of the cheat sheet that you'll notice is there's actually 3 different types of hydrocarbons, so here's some vocab for you. Alkanes, alkenes, and alkynes. Now look at those words, because one of the things that drives me crazy is that you'll never know how to pronounce which one. So look again, all right? Alkanes, alkenes, and alkynes. It's the enes and ines that usually mess y'all up, and I want y'all to try to be good at it, all right? Some of the major distinguishing characteristics between the 3 types of hydrocarbons, all right, compounds that are just carbon and hydrogen, are whether or not there are double, triple, or just single bonds. Alkanes are the simplest. You'll notice that the structure listed there is all single bonds. Alkenes are a little more complex. You'll notice there's a double bond present, and alkynes always have at least one triple bond present. I'm not going to make you draw the shapes, but you do want to be able to recognize the shapes and identify and connect them to a vocab word based off those bonding structures. Our alkanes, alkenes, and alkynes are always going to have carbon with a subscript followed by hydrogen with the subscript. This nomenclature system is different than anything we've done all year long because there's going to be a mathematical relationship between these two numbers. If you look on your cheat sheet, the mathematical relationship is there. It goes like this. If it's an alkane, meaning it's going to end in the suffix ane, then the carbon is going to have a number, and the hydrogen is going to have twice that number plus 2. And I'll show you what that means if your head just spun because you hate algebra. If our nomenclature is going to be the double bonded guy that ends in ene, then the carbon is going to have a number, and the hydrogen will just have twice that number. Again, examples coming. And finally, if it's a triple bonded ine, then carbon's number will again be doubled, but then less by 2. Make sure you write everything that I do in regards to these examples. Let's start off by, we have to go both directions. Let's start off by writing the names. For example, if we have C2H4, I know it's organic because it contains carbon. I know it's a hydrocarbon because it's just carbon and hydrogen. It's the relationship between the numbers that we care about. Now, let's look at this number first. The very first number is going to pick one of my prefixes. That's over on the other board or on the other side of your cheat sheet. What is the organic prefix for 2? F. So write F. So the first part of the word will always be one of those prefixes. The second part of the word will always be one of these suffixes. The question is, how did we get from 2 to 4? Now notice that all of my suffixes double the number. All of my suffixes double that number. But then some of them add 2 to it, and some of them subtract 2 from it. What happened here? From 2 to 4, we just doubled it. Sorry, 2 and 4, you're right. 2 and 4 is a bad first example. It looks like we added. Look, listen again. No matter what, we're going to multiply that number by 2. If that's all that we do, it's ene. But if we then add stuff to it or subtract stuff from it, it's one of the other two. So this is going to be ethene, because all we did was double the number of carbons. And that's it. These are the simplest names we've ever dealt with because they're all one-word names. Ethene. Let's do another one. It's a hydrocarbon, so we will use our organic nomenclature rules. The first number will pick a prefix. What's the organic prefix for 9? Non. N-O-N. Everybody see where I got that? How do we get from 9 to 20? Now, no matter what, we have to double the 9. All of them double the 9. So 9 times 2 is 18. All right, well, that's not an 18, so it's not ene. If it's just double, it's ene. How do you get from 18 to 20? You add 2. This is nonane. C9H20 by adding ane from the plus 2 is nonane. C5H8 is a hydrocarbon. The first number is a 5. What's the prefix for 5? Pent. All of my suffixes double to 5. 5 doubled is 10. That's not a 10, so it's not ene. How do you get from 10 to 8? Minus 2. This is, somebody say it. Pentine. There you go. Pentine. You try a couple, then we'll go the other direction. Name both of those. Let me know if I can help. Let's see how you did. They're both hydrocarbons because it's just C's and H's. That's the only reason we use this naming system. There's one carbon there. The prefix for one is meth. We need to get from a 1 to a 4. We always double the number. 1 doubled is 2. To get from 2 to 4, we have to add 2. This is methane. Another hydrocarbon. The prefix for 6 is hex. To get from 6 to 12, we always have to double it. 6 doubled is 12, so we didn't have to do anything else, which means it's hexene. Questions there? You've got to be able to go the other way. If I give you the word, you've got to write the compound. All right, there's no crisscrossing of numbers or any of that. It's very straightforward. So let's give it a try. Somebody say that. No, don't say butane. I mean, my 6-year-old would think you're hilarious. But butane, not butane. Whenever you see a one-word compound, all right, these are very obvious when it's organic because they're the only ones that look this short and funky. Right away, for this class anyway, we know that we only name hydrocarbons. So put the CH right away. We've just got to get the numbers. The bute will give you your first number. What's the bute? It's a 4. The ane will tell you what to do to that 4 to get the H numbers. Ane says double it. You always double it. Well, 4 times 2 is 8. And then add 2 plus 2 is 10. Butane is C4H10. Decyne. It's my funky organic word, so I put a C and an H right away. Dec will give me how many carbons? 10. Ein says to double the 10 and subtract 2. What's 10 times 2 minus 2? 18. Decyne. You try a couple. Write the formulas for both of those. They're both my funky one-word compounds. So I know both of them are hydrocarbons. Hept is 7. Ene says just double it. Oct says 8. Ein says double it, but then add 2.